Well, we have excellent panelist or speaker today. I think I pretty much enjoy all your talks, and I think it's a very exciting field when I listen to your presentation. But I think there are a lot of questions that we still need to discuss, and I think a lot of audience are eager to know, because during this very short presentation, maybe you cannot say too much. So we have question prepared and sent to you in advance, right? Okay. So there are many questions. So I will start from the first one. Is we're concerned about the AI structure for robotics. The question is like, what do you think about the roles of general purpose AI versus specialized AI? I mean, general purpose of the AI is not general AI. GAI is like a human. General purpose AI is maybe it's an AI that can cover a large area of applications, where specialized AI, where you focus on specific applications. So what is the role of these two AI? Because when you develop AI was cover a lot of domain, then you have to develop some very good business strategy, right? Because you cover a lot of different domains. But for specialized AI, you can focus on specific value. That will be easier. So what is the role, or what is the strategy when you develop that? That is the first question. Let me go through all the questions. The second one is how are the AI model being optimized for real-time, low latency performance? I think from Invenience talk, you already mentioned about that already, right? So maybe some of you can have more explanation of that. The third one is what is your take on balancing centralized and decentralized intelligence? Centralized means cloud intelligence. Decentralized means edge intelligence. I think in one of your presentation, you are saying about the blur of cloud and the edge, which I don't really quite understand. What is the blurring of edge and the clouds? They are quite two distinct devices, right? Okay, so these are the three questions. Maybe maybe the first question: what is the general purpose AI versus specialized AI? Who will be the first one to give some comments?
Sure, I'll break the ice.
Yes, sure. Thank you.
All right, sure. So maybe before I answer the question, I do want to say to Ricky, we actually exclusively use Intel 13th generation CPUs.
Okay.
in our IPCs. So sorry I didn't give a shout out. I should have been more prepared. But yeah, the specialized versus global. So obviously, like, our talk was about specialized intelligence. So that's the business strategy that we've chosen. I think our perspective, or my perspective, is that the global world models are going to be amazing and are going to be transformational and are going to be more useful for social robots, even for industrial robots in the end. But I think the journey to get there and to be able to use it in the real world, whether it's in a factory setting or safety issues with a home setting, I think it's a long road to get there. Data is the gold mine for where we're going. With AI and specialized models today, we feel that we can get to the higher, 99 point, however many sigmas you want to go. We feel like we can get to the higher sigmas that are going to be reasonable for a factory in a shorter time, and so we can deliver more value in a shorter time. But it's a bet for the moment.
Yeah, but my feeling is that when you produce a product with many functions, you are really prone to a lot of errors, right? Your probability of making mistake with a product with a variety of functions versus a product with a specific function. The product with specific function is very more easier to be robust. So, but in the future, how do you produce the AI? We cover a lot of area or cover a specialized area. I think maybe I think we should say it's Chairman Guo. Okay, Chairman Guo. Maybe you can share some of yourself, because you are developing the product right now, right?
Yes. So even for us as well, we're the same path where I think specific models are very, very important for us because, like I said, I think from our strategy, we're sitting on specific data ourselves. We're just trying to extract as much value out of that as possible. And we find that in that environment, it's much easier to hone in kind of the parameters for everything that is needed, where we can make sure, like you mentioned it before, we can get to that 99.99% a lot faster, right, compared to the general model that we use. So we leverage as much specific data as we can because that will build a difference compared to whatever you see right now, where the foundation models are going. We can make a difference from our perspective from that point.
Okay, great.
I was just going to add something in, and I think as I mentioned during my presentation, I built myself around experience, and I prescribe to this thing called KISS, keep it stupid simple. So I've been building products for 30 years, and if there's one thing I know, that the more complicated you make something, the more likely it is to fail. So, when you look at these specialized models and the specialized outcomes, particularly in manufacturing, if it's very specialized, it's contained. And I think you mentioned that as well. So in my principle, when I look at that and I look at how that is being foundationally done in the use cases that I'm driving, whether it's in visual-based AI, I'm looking at a specific thing. I'm trying to figure out whether there's a defect or the fruit is bad. Keeping it simple means that you can implement something relatively quickly and get a better outcome. Yes, of course, we're all complex human beings, and as robotics becomes more complicated, we want to add more capability to it. But I firmly believe these specialized models, certainly initially, are the area where we're going to see growth because we want to see outcomes. We want to see business value. As we see business value, we trust the technology more. We'll expand the capability to more of I'd use the general purpose ones right now. If I'm lucky, I get a 30% accuracy rate, if I'm lucky. So do I lose trust in that? And I don't want to do that in manufacturing. We can't afford to lose trust. So my view is on specialized models, they're absolutely fit for purpose right now. What we need is an industry to learn through, to start adapting. I mean, Freddie, you mentioned all the things you're doing. I mean, you could go everywhere and you could go nowhere. Yeah. So specialized is, and I noticed you have a quadruped. You mentioned it multiple times. You're specializing around vision-based off of the quadruped. That use case, security came out. It's almost like you were almost honing in. I'm getting value in there. I'm specializing before I go into my next generation.
Thank you. We have a question about the centralized and the decentralized architecture. Maybe Festo, you can explain more about this, because this is very important, right? Because it will concern about how you deploy these products.
Yeah, I mean, I liked what Freddie also had. So you said 95% could be kind of on the device. Yeah. On the edge, and this is also what I have basically shown today. It's also what we believe, that a lot of these simpler tasks, I would call it, can be done on the decentralized solution, which means on the edge. Your question was also to what does it mean blurred?
Yeah.
Yeah. So maybe blended could be another term, or co-packaged. That you have seen also these simulation models. This you cannot do on the edge. You have to have something on the centralized, because the computing there needed is enormous. You cannot do it. And also, if you think about all of this robot, maybe what I didn't mention is they are mainly or the movable battery powered. So this is a key thing that we need to also think about, that we cannot overload the processing needs on the device. So we need to break it down to simpler tasks, even specialized, into the use case to do it on the edge on the device. The more complex one still to be running on the servers or any other premises. So this is what we see, and this is also the path what we are, let's say, suggesting or going with our new devices.
Yeah, from my understanding, that when you train the robot, you can use the cloud resource to do that. But when you try to implement it in the edge, then you cannot rely on the cloud, right? So what is the, maybe I'm asking you a question. How do you balance those things?
Yeah, no, I think that was great points by Nanette, and I think the dimensions are right. The power consumption, the processing time, and then the other dimension is maybe security and privacy, yes. and what's happening in your factory in real time. Can you rely on a connection to an external data source to run your factory? So I think you have to take into consideration all of those things, and you have different processing that you do in different places at different times. So the training, when we talk about how many parallel processors you need, no office is going to be able to do that within their building. And so that's where we do most of the simulation training on the cloud. Yes. When we go into a factory for running an operation, we have the industrial PC running Intel CPUs. That is, we're running the foundation models on the industrial PC during the operations itself. So we don't depend on a cloud connection for that. So I think multiple dimensions to consider.
Great.
Okay, yeah. I'd like to say from the perspective of the social implementation, in this topic, we like to think about to use the multiple robots in the area. In that case, the crowd decides the mission or strategy for each robot. Each robot can accept such kind of a strategy and how to think about itself. So-called, if we can imagine the baseball team, each player as each edge, and each supervisor as on the crowd, and the mission as competes the championships. So how to do that? Each player should how to do that, or hitting or catching the balls, and that depends on the robots. It's on the edge. To enhance this topic, inside of the robot, the centralized and the decentralized program is the same in the inside of the robot. Because in this stage, we are concentrate into only one robot controller to move the hands or legs. So I think about it's very high cost or high ability for the controller. It leads to the very expensive. So we would like to decentralize inside of the robot as well to move the hand itself by the local controller or local tips and to move the local legs. And that's a very replaceable or very easy to cover for the new robot or combined robot. It's a same strategy, not only for the cloud and the edge and inside of the robots. It's very similar, I think. That's my opinion.
Yes. Bushman, you want to add something?
Yeah, so thank you, Hamaguchi-san. I because of that, I want to add something that even just our applications of what we're using and what we're seeing, we had to the previous way that we were training these quadro robots, where you deploy a map, you scan, surveillance the whole environment, and it was a set environment. But with that issue comes in what you mentioned about the security, right? So people will ask us, if we take away the dog, I can just upload the map of your building and where we need to be. So we had to rethink the way that we're training these dogs and how do we deploy the models on there, right? The previous way is models where we run through the simulation within this environment, we train the tasks that they needed to do, but now we had to separate the two to make sure that the security front is secure. Where on the edge perspective, all they need to do is kind of like a human task. You give them only physical tasks, where patrol, you just through a certain, coordinates, and the same thing. When you see a door, when it's supposed to be shut, you need it to close. But I don't give you any kind of other, critical information on the edge side. That can be deployed on the cloud side. So that's kind of going back to where you're talking about blended of cloud and edge side, where it's kind of like a human, if you think about it, where we can, go somewhere in the world that we've never been, but we can pull up a Google map, we can figure out exactly where we needed to be. So it's kind of like on the edge side, but I have a cloud device that gives us the coordinates that we need. But I would never remember where I need to go in Spain for a certain restaurant just because of that, right? So I think now we're actually in that transition stage where that's going to be an important topic to figure out. how much task we can put on on these dogs, and how much can we upload onto the cloud, and how do we make sure that all the data from the security perspective to be, you know, secure, and where customers could be feel safe, where a lot of data are pretty crucial to them. Yeah.
Yeah. What you want to? Add
Yeah,
something?
it's just, it's, you know, you learn so much when you come to conferences and you meet wonderful people like yourselves. And it's really intriguing and interesting to me in terms of, sometimes I look at it, it's just a data problem. But as you learn something, you're creating more data. So you're learning. So there are so many layers and levels here that are involved. You know, like you mentioned, mapping data. What do I want to share? Now, one of the things that we're very keen on, of course, is we want to innovate. You want to get that experience. So I want people to be able to interface and work. That's where cloud compute comes in to some extent as well. I work in factories, and we have companies that I'm working with, they have the same factory in 10 different locations, okay? So they're doing similar operations. Now, they want to be able to share what they're doing at that factory and learn. So they get training from the cloud that goes down. They do specialization. They want to go back up and do the reinforced learning, and they want to share it. But there's data that they don't want. So one of the things that we're working on Intel is, how do you provide an infrastructure that's secure around the data itself and the data that's created and the way that you work with data as well. And I think it's a subject that we will continue to work at as an industry. How do you unpack that in the right way? What is shareable? What are the rules about something and how we share it? To your point, even collaborative robots. I might have a robot from one manufacturer collaborating with another one. Am I giving my IP away if I share something with that other robot? Or am I making it safer? So we are working as an industry certainly on how you enable that architecture and obviously build the data sharing models and the way that we want to work going forward. So I believe cloud compute, that's why I look at it as a continuum. I see all levels of compute exist. What I'm looking for is, how do I share amongst that compute the right information in the right way within the right rules? And I think that's very important that we as an industry understand that as we're building more and more complex robots, be they social, be they manufacturing, be they in any environment.
Yeah. Okay.
Yeah, maybe just to add on this one, I mean, it's the keyword of standards or something like that. So robotics is an old industry in some cases, but also it's a new industry in the other cases. So what we see is that, what I see as well is that the standards are still not there. For example, this, everybody is cooking his own soup. I think soon we will come to the crossway to say, hey, let's share a bit, at least to have a basis ingredients, and then you can still cook your own soup going further. So I would say standards going forward for this area will be something to be looked on. Of course, in the whole robotics industry, I would say the safety standards, but this is a different topic, are also still going to be evolved. If you look at the humanoids, I saw some out there. They are still just standing, I would say. China mainland a bit, they are moving around, but always with somebody next to it. And this is also a topic, I think it's going to be a lot of discussions, what safety you need to put in. Is it same functional safety as for the car? Or is less needed? So this is going to be an interesting topic. I'm also eager to learn more.
Oh, yes, yes. Well, even the autonomous driving has been deployed on the road, but there's still no standard for that, right? So it's a very difficult question for AI robotics, but I think this is very important. As you said, there's no standard, there's no sharing. There's no sharing, I think the progress will be very slow. Yeah, okay. So let's move into the second one, okay? Real-world deployment of AI robot. I think the first question is, I think everybody is very interested to know, what are the biggest commercialization challenges for AI-powered robotics? Okay. The second one is, could you share successful industrial integration examples? The third one, how do you ensure safety, reliability, and intuitive human-robot interaction? I think maybe the last one, Yamaguchi-san, you can shed some light on this one. But maybe you're trying to answer the first question?
I can answer the first question.
Okay, great.
I'm living in it. Yeah, I think the biggest challenge for us to be able to commercialize and be able to deploy on these use cases, I think again, there's still a lot of software tools that need to be designed, they need to be fine tuned because, and you know, from our perspective, we really are trying to build the whole system. Like we mentioned in the deck, our robots are actually integrated with what you already traditionally have from a security perspective. Everyone has a badge, scanning card, access control. You have normal standard cameras. How do we integrate into that? It's that tool needs to be, you know, pluggable for whatever, you know, like you mentioned about the robotic arms. If people want to use ABB, people want to use KUKA, it's the same idea, right? How do we make sure that it's pluggable for people that are using not only the Luminous security cameras, they might be using, you know, Vivotech cameras, they might be using different ones cameras, right? So that, and another part for commercializing for robotics for usage is, you know, how fast can we deploy them and how accurate can we deploy them, right? That's another thing. How fast can we train these data and be accurate? Right now, even for us, deploying maps and that, it's already been fast than before. Right now, we're about 2 hours for a whole floor, but, you know, previously you might have to take, you know, 2 days to be able to build some sort of 3D map in order for your dogs to be trained in it. That needs to be changed, right? Because I can't send my engineers out everywhere in the world, if I got any business anywhere in the world, and have them train and stay there for 2 days just to set it up, right? It needs to be a plug and play kind of thing. So in order for that to happen, there's a lot of software tools that need to be fine-tuned. How does a robot recognize the maps? How does the robot recognize the world? That needs to be fine-tuned, and that's a huge challenge right now.
Great. Yes.
That?
Yeah.
Yeah, different types of the angle of the opinion. I'd like to propose that like industrial robots, the KPI is how efficiency or running time, and that is a basic KPI. But in the robot in the society is how to continue to use that. That means how to configure it by the actual people, because for example, the single task for the cleaning, and that's it's easy to say the cleaning, but every people change the procedure or customize the operation. In that case, we just put into the cleaning robot, hey, please use that. It's very not useful because that's not customized. So in that case, the customization is very mandatory for especially for a social robot, by way of the communication. Hey, do that by this way or the other way. Its flexibility is very important for the KPI for the industrial commercialization for a social robot. That's me.
Okay.
Yeah, I think those are both great points. I think robotics and AI comes with too many challenges, so it's hard to pick, you know, what's one. But maybe I would say somewhere between reality disconnect or the hype curve is probably the biggest challenge for commercializing robots. You know, we've been seeing Star Wars since what, 75 or something like that, and we're still not there yet. Yeah. And I think, you know, when you talk to customers, even if they're pretty advanced customers in automation, the expectations of what you can deliver at what cost is still pretty far from the reality. So, you know, and now we're bringing AI into it, which just adds a whole nother level of expectation disappointment in a lot of cases, because, you know, we have success with ChatGPT, but if you go into a factory or into your home cleaning, you know, would you accept a 50% success rate or an 80% success rate for good models? It just doesn't work. So you have to get beyond the hype and talk through, you know, what can be achievable and in what timeline. That's difficult.
Yeah, I think it's very interesting. I'm thinking about the cleaning robot, the robot that enter home. I think that in the beginning, the cleaning robot, they fail a lot, right? They just go into under the couch and they never come out. But the people are still buying them because I think that solves a certain problem, right? So I think maybe there are some pathway, okay? First, we will come up with some intelligent devices that can solve problem, but still make mistake, but not serious mistake. Yeah. But people will gradually get in them, get used to it, and gradually making progress, right? I think that's if you look at the cleaning robot, the Roomba, it's just follow the pathway, right? It's become very smart right now. If you go buying some cleaning robot, compared to maybe 10 years ago, it's much more intelligent. First of all,
yeah, on this commercialization topic, we also have to differentiate the end user. I mean, industries will be certainly adopting it. Of course, you're looking at the ASP for such, let's say, robots in a lot of cases. Now, this big thing about humanoids, it's going to be the same thing. I mean, of course, you see in the news, you get it for a few K, yeah, but it's, in my world, not usable yet for even consumers. So we also will need to see on the whole manufacturing supply chain and scaling to bring this to a certain level where scale can happen. And I think in a lot of cases, consumers will contribute to this. In other cases, of course, industries will be the leading force. I mean, as a consumer, you won't buy industrial robots, but certainly you might potentially, if you have a dull task, buy a smaller cobot for something at home. It can be something repetitive. So I think this is also an aspect that needs to come in place to make it commercially fly beyond the whole AI that is up there.
Okay.
Yes. I'm just going to add a couple more little things here. Firstly, I want to say, may the force be with you. I think it's really interesting. I'm going to go back to something Freddie showed on one of his slides. And look, there are many things that we're overcoming in terms of challenges in the industry around robotics, especially the more complex that they get. There are areas where I think robotics is growing very fast and we're getting better outcomes. In the area of safety, for example. I mean, when you talk about harsh environments where putting people in a harsh environment is going to cause harm, robots are getting huge amounts of traction. And they're growing, and they're getting faster, and they're getting better. The use of drones, for example, in California, the recent wildfires that you probably read about last year, they're now using robotic drones to analyze the power lines and where things are growing. So we're seeing a lot of innovation and a lot of growth there. And I'm going to go back to where I see a lot of challenges in manufacturing, which is reconfiguration of manufacturing lines, particularly even in fixed function robots as well. We want to see more flexibility, more growth. I think some of the stuff you're working on, Matthew, around some of those models you're working on, and that's that software layer. I agree with you. I think there's a lot of innovation going in terms of that. We need to make that go faster. We need to get that reinforced because ultimately you're building models that need to go out onto the real world. We need to get that real world connected back to those models, closing that loop really fast. Software needs to come. I think the connectivity to the cloud needs to come. But we're already starting to see, I think, manufacturing, certainly in a lot of areas in robotics, really starting to really grow very, very fast. And I think that's going to expand. It goes back to what I started with, that keep it simple. Work on the use cases you can, land and expand. We see the innovation that's coming in here, tie that to some of the work that Intrinsic are doing, some of the work that you're doing in Infineon, and then tie that to real-world examples of the data. And I think come back here in 2 years, and I think we'll be in a very different position from where we're at today. There are challenges, but believe me, the industry's working very hard to overcome those challenges and help scale.
Okay, great. I think we'll touch a little bit on the edge side, right? I mean, we already talked about that. I think a lot of expectations from the audience, particularly Taiwan industry, they are expected to know that what kind of edge computing will be useful or will be developed in the future for this AI robotic. I mean, from my experience, is that when I develop some AI model, currently it's very difficult to choose an edge computer that will fit the model. Or if I want to expand in the future some more functions, maybe this AI chip, it won't provide enough computing power. So what should I do next? This practice is very different from the traditional programming and computing practice, right? So how do we develop this AI computing power in the future to satisfy the AI robotic needs? Maybe you can have some comments on this.
Maybe this is an area I can.
Our customer will request.
Look, I'm going to say something that's probably a little bit controversial for a silicon person, but ultimately, I want the silicon in a way to disappear in terms of its complexity. So we need to be working on Intel, and I talked a little bit about this. We are bringing new silicons coming out. You're starting to see tremendous innovation. We're going from 10 nanometer to 7 nanometer to 4 nanometer, TSMC going to 2 nanometer in the very near future. Compute power is growing exponentially. I believe as we go forward, and I've certainly seen new types of compute coming as well. I firmly believe that the compute that we're seeing today is not going to be the compute that's going to be there in 10 years. Robotics, when you talked about artificial skin, I was working on a project with 100 million sensors in a robot. 100 million sensors. Imagine the data that's being created and the speed that's being created and the decision matrix that you've got to make based upon that data. There isn't compute that we see today that can do that, but it's coming. But ultimately, that compute is growing. You're going to start to see more and more of that coming out in the market as we go forward. But what I want to do is make sure that that compute is abstractable from the people that are working on the applications and services above it. We need to make that complexity go away. So the innovation in AI, innovation in social robots, innovation even in data and the work that you were talking about there. I want to make sure that when you do that, it lands and expands on the right silicon at the right time. So we want to, in Intel, that open ecosystem, enabling the best experience, of course. I want it to be on Intel, but I want to make it easy, and I want innovation. I don't want you to have to worry what silicon is underneath. You need to worry about the models. You need to worry about what you're trying to create. Your engineers, your developers then need to deploy that at speed. And our job in Intel is to make that compute power that's needed and make that complexity go away so that when you deploy those models, those worries are not there. You get safety, you get security, you get the capabilities that you want. And we will continue to develop compute. And I believe you'll start to see in the next 3, 4, 5 years, I'd love to come back in 2 years and tell you about a different type of compute that's coming, that is a different type of engine, reasoning-based engines, nothing like you see today. And that is the future of robotics, where you're really seeing some innovation.
Great.
So I fully agree what you're saying. I mean, I'm coming also from the silicon corner, Ricky. So certainly, we as a human, we have one brain. So we think a robot should also have one central thing. So I would see it a bit different. I would say, yes, you need a main brain, but a lot of this AI topics could be also mentioned here on the other solutions, that you can put different computing powers for different use cases. So if you have 1 million sensors and you overload your brain is gone. Yes. So better have a bigger, smaller brain and then different other ones. So I think going forward, this is certainly what we're going to see. And also from our side, from Silicon, we want as well that whoever is working on robotics and AI doesn't worry about, hey, do I have the right security protocols that are needed, or how do I connect maybe my solutions with this one? How is the communication in the robot, for example? This is also a topic we could talk about for days. Yes. There is no standard. There's Ethernet, CAN. Like what should we use for the data transfer, for example, in the robot? So this is what we want to also take care about with partners, with the industry, that whoever is designing robots can focus on making them hopefully move in the way we want them to move.
Yeah, certainly we need a lot of support from the silicon area and also the communication. But I'll go back to Chairman Guo. You are making a product now, so you have to decide what kind of edge computing you need, right? So maybe you can give us some idea of.
Well, I think I'm glad to hear that, I don't got to worry about any kind of computing power. You guys will take care of that for me, so I don't have to worry about that. No, I think for us right now, there's a saying, if given it enough computing power, our software engineers got to figure out a way to use them all, right? So there's in infinity, and it would never be enough for them. The problems can always get more complicated. The issue can always get more complicated. They can always want to do more things. And I think it's our duty from a user perspective and also the edge side to really going back to what we talk about, what needs to be on the edge, what needs to be on the cloud side, and how complicated do these problems need to be, right? We can't duplicate a human just yet. I know people are thinking about we can just do a robot that just do what a human task would be, right? But I think we still need to diversify a lot of different tasks, what needs to be done, even the information that are they're coming in. We need to pre-filter them, right? From a camera perspective, you can look at a whole room, you can spot 1,000 things, but are really all that important? But it needs to go back to what these tasks needs to be done. So I think that filter from our perspective needs to be built in. And so the data transfer and how do we, manage data, it's far more important compared to how much data do we need on the edge side, how much computing do we need on the cloud side. It's really going back to that value add. What value can we bring to the customer? If a patrolling, all they need to do is make sure that there's no blacklisted people coming to the on-site, then all you need to make sure is do human recognition, right? Facial recognition. That's all you need, and nothing else matters. So it really goes back to what the original task is. Stick with that, and making sure that the data revolves around that, and that's all the data you need, right? It doesn't really, so it doesn't need to be overcomplicated.
Yes. Okay. So let's move on to the last one, the ecosystem and collaboration. The question is like, what kind of cross-industry collaboration is essential for AI robotics? I mean, I think the robot is an integrated product. It requires disciplines and expertise from different fields. The second one is, are there open standard or frameworks needed to accelerate development? I think we already touched about that, so maybe we can also have more explanation. The third one, I think, is also very crucial. What advice would you give? Okay, you're coming from the large companies, and so what advice would you give to startup companies? There are a lot of young men. They imagine this field will be an emerging field, so they will pitch their efforts into the startup or research lab. How can they join this field? Okay, so those three questions, maybe we can first start with Intrinsic.
Sure.
You actually, are you a startup company? You are not a startup company,
Yeah,
right?
whenever I explain that, I say we're a startup, right? We have a fortunate advantage of our big brothers and sisters. So yeah, I think I'll start with the ecosystem question, because I think it's interesting and very relevant to us. So we're building a platform. It's relevant to all of us, but relevant to the story I was telling for Intrinsic is that we're building a platform and building an ecosystem, but we're also disrupting many ecosystems or partnering with many ecosystems. It depends how you look at it. I think in the world of robotics and AI, at the end of the day, there's no one company that could possibly do everything, that every use case, every need, etc. And so I think there's some Venn diagram where all the ecosystems overlap and everybody can still provide value and benefit, and finding out how to grow together is more important at the end of the day. When it comes to AI models, I think it's very difficult for smaller companies to build AI models today, just the amount of data and compute that you need for it. Most of the AI models are coming out of larger corporations, a few larger corporations, to be fair. But that will change. I think we're figuring out, compute power increases, application approaches change. And so, we're finding some new startups that come out and challenge the bigger companies. So I think, ecosystems are absolutely key. I totally agree that standards need to improve. It's lagging behind in the world of robotics, never mind AI. And so I think this is how we'll start to speak the same language, learn how to share data more appropriately, and at the end of the day, grow the industry together or industries together.
Yes. Okay, great. Maybe Yamaguchi-san, because I think Kawasaki is encouraging or incubating a lot of startup in this area, right? Yeah. So you can share some of your thoughts.
Yeah, my advice for the startups teams is as fast as possible to collaborate with big company. Big company means have the actual field. So many actual field. That means we have to find the new problem statement actually, no theoretical. So that's would be a motivation for to develop the new technology or new solution with a bigger company. Using the some money for a big company, so it's very useful for the startups. Also, it's very useful for the bigger company to use the cutting edge technology. It's very both win and win collaboration, I think. So collaborate with the actual field company. That's very promising. Such kind of the hospital or construction site or education site, and that's a very helpful and very meaningful, I think. That's my opinion.
Okay, thank you.
I think one area as well, and having been involved in many startups and in big companies as well, look, you know, especially in this environment as well, if you're a startup company, you know, hopefully you've got what I call a USB. You know, you have some sort of unique value proposition that you're bringing to the market. So I always say as a small company, focus. Make sure you're focused around what you believe you can deliver. And then as you focus and you deliver and you prove that technology, find a way of delivering that technology through to an end customer that's driving real business value. Once you start creating that and you've established probably some amount of revenue stream, then I think it gives you that opportunity to expand as well. So in the world of AI and robotics right now, I mean, particularly robotics, it's a high buy-in. You know, it's quite an expensive business to get in. AI, slightly different models, but ultimately, you know, there are a lot of companies out there right now, and I think there's a lot of innovation, there's a lot of opportunity. It's on us as an industry to create the right hooks, the standards, etc., and we need to evolve that. But I think if I was a startup and I'm promoting that ecosystem, I always say, you know, be very focused on what you're trying to do and the outcomes that you're trying to get. Prove that technology, because if you prove that technology, when you go back into the ecosystem and you're trying to expand upon that value you're creating, you want the proof points to come out. If you don't have the proof points, but all you have is the ideas, I guarantee somebody else will have the ideas.
Okay. Yes. Yeah, Matthew,
I just wanted to add one more thing. I think to tie a little bit together to everybody's presentation, we all talked about data sharing in some way and open source ecosystems as well. So I think, you know, connecting the ecosystem topic and the startup journey, open source is a great way to get involved. You can learn from algorithms and tools and systems that are already out there. You can leverage them for your systems. You can participate in those ecosystems and become a member, which also grows your network. So I didn't mention it, but I was previously from Open Robotics, where we did ROS and Gazebo and OpenRMF before we got acquired by Intrinsic. So open source is very passionate to me. I just didn't want to talk about it during my presentation, but glad I got a chance. Thank you.
Okay. Mr. Benedict, you want to add?
No, I just want to add, I mean, listening to all of it, I think we should partner up more in this round.
Oh, yeah.
Because everybody provides something. It's a kind of a heterogeneous round, so it would be a good fit, I would say, to take a beer afterwards. And
Okay. Yeah. President Guo, you want to add more about this startup or ecosystem?
Yeah, I think from the ecosystem perspective, like we mentioned in our presentation, I totally agree. I think this is right now the day and age where everyone kind of needs to work together to develop this industry together, because everyone has what they're specialized in, and with the robotics, that how complex it needs to be, everyone needs to kind of bring everything their best onto the table in order for this to work, right? Any kind of small piece that's not in the right place, it could fall apart. So I think that's collaboration is key, and I think this industry, everyone needs to be involved. Going back to the startup, again, thank you guys for pointing that out. I think it's all the key points, right? Being really focused on exactly what you needed to do, and going back to, you know, the data point, trying to figure out a player that you guys can partner with to be able to drive the data that you need to solve that particular problem, right? Focusing on one thing. And I just want to add the one last thing where I think speed is very important. I think speed right now is the key. Right now we're at this day and age where these robots, they need to take iterations. They need to get better. They need to take time. They need to develop from 1.0 to 2.0. But that takes time. And whoever gets in first, you're going to see the problem first. You're going to be able to solve the problem first. that at the end will build up a lot of the competition barriers that you will have down the future. And like when we were talking about the AI tool, open source, it lowered a lot of the entry barrier for this development, which is why speed is much more important now, right? The faster you get in, the more data you collect, the more experience you have, you're gonna be far more ahead compared to how complex the model could be. I think that's one thing I would suggest.
Yes.
Yeah, just on the speed topic, I mean, we're coming from a big corporation, I think Intel as well. So I think this could be or is a really big advantage for startup. Is this speed, speed.
Okay.
I mean, big corporations, of course, we try to be as well fast, but we all know it who are or worked in a big corporation sometimes. Sometimes you're in your own universe, coming back to Star Wars. So I would say this could be a really big advantage for startup to really show the speed and also cooperate with the big guys to show them that you could bring in the speed that maybe they are missing.
Yes, I think we should encourage startup because this AI robotics create a lot of imaginations, and we need young talents to expand their capabilities and to really bring in good ideas. Some of the startup may be later on be acquired by some big company, but their value created will give us a lot of benefit in the future. So we are ahead of time in 10 minutes. So I would like to open the question to the floor. Yes, please. Yeah.
Thanks for Dr. Hu for this excellent conference.
No sound.
I would like to thank Dr. Hu for this excellent conference, and also all the panelists for very inspiring talk and discussion today. And my question is for Yamaguchi-san, as we are also interested in social robotic, and one of the key problems we think that's very hard to conquer is how we can make the robot fully autonomous, which means that we remove the people intervention out of the loop or without any human control. And this is so challenged that I think we are seeking for partner to solve that. So do you have any experience or maybe opinion on that? Thank you.
Thanks for your question. For my perspective and for our company's perspective, the free autonomous is far from the here. And to prepare for that, we prepare for the remote control and semi-autonomous control. To make a safety system, the remote control is mandatory, even in the future. To ensure that for humans' safety. So free autonomous is ideal, but I think it's not mandatory because it's backup from the human or other system to keep the safety. So okay, you can do that.
The reason I'm asking this is that per Tesla's point of view, they are going to sell all this humanoid robot to the home environment, which is almost essential. That I mean, you cannot expect a grandma or a housewife to control a robot, right? So it has to be very adaptive in such a way that it is almost fully autonomous. Need a minimum human intervention, and if we are looking at a market that size like a billion a year, then I think fully autonomous is a must. There's no way you can avoid that. Otherwise, well, only the engineer can control a robot, right? So, and this also apply to drone. Okay, so yeah, so that's why we see this as a big problem. I'm from Realtek, so actually I have a similar background myself. So, but anyway, this is a big market that we are looking after. So I'm looking for maybe some other people have some opinion on that. I think.
Full autonomy. It's a pretty challenging question.
I think so.
Yeah.
But I have the same image for a future business or future perspective. That's I think it's great. But we have to make some steps into the final stages because. Yeah. Okay. But
Okay.
we like to cannot do that by ourselves. That's free autonomous. So we'd like to collaborate with some other companies and academias. That's at this moment. Yeah, at this moment, I can say that's all. Sorry.
Thank you so much.
Yeah. Oh, okay.
I was just sorry. I was just going to add very one. I'm fortunate enough to work with some of the companies that you mentioned, and I agree with you, Yamaguchi-san. I think it's some distance in the future, and I'm going to repeat something I just said earlier. The type of compute that's going to be needed for that type of autonomy, I don't think we see is in the market today. So I believe it's coming, but I believe it's out there in the future to some extent. Now, even in the one that you've mentioned earlier, what defines autonomy? So, am I autonomy and I don't talk to anybody for 10 years? Am I autonomy that I do a task for an hour and I connect back in? So there are levels of that as well that I think we need to step through as an industry as well. So I think my question will be back to you as you start to look at that. What is that journey we go on towards full autonomy? What's going to be needed from an industry to drive? The outcome is, I think, correct.
Yeah, that's. I think all of us might agree that there are so many levels of autonomy, right? Even the tree or plant, they have some kind of autonomy in a way that they actually move a little bit when something wrong, right? So when we look at all these biological beings, okay, they actually have certain different level of autonomy. So if I put a term here like a generalized reflexive system, does that make sense to you? A generalized reflexive system, okay? Or maybe a word maybe you heard about it, that's a proprioception system, meaning that all these things, it has to be distributed so that each part can collaborate together as a whole.
To create.
Yes. Yeah, so that's what we are approaching today. So that's why maybe if you need maybe intrinsic or Kawasaki will like to talk to us a little bit, that we are working on that. Thank you so much.
You want to add something?
I just wanted to add because you said that Tesla is saying putting the robots there. I don't want to be the boom maker here, it's going to take longer, but just look 10 years back when we had the cars coming on the street, we're going to have level 5. I think this year was the year. So where are we now? I think level 2, level 3, that's maximum. So this should be something just to showcase that potentially could not be so fast. I hope it will be faster. It might be
ask you why why flying on the sky, you will never catch it. Yeah. It's not because of the computation, right? Okay, the autonomous car are not moving. I mean, they collide a lot because they compute. If they compute, it's delay, right? It cannot be very exact. But even for the flight, it's so hard to catch it. Okay, they don't have a lot of neuron, right? So that's my different level of autonomous actually work. And that's what we are approaching today. Thank you so much.
I think if we discuss autonomy with a different level of perception and ideas, we'll take another session to do that. Any other questions for our panelists? Yes, please.
Sorry, I have a question about the hacker. We know that hacker always will attack. If you use the AI to attack the robot, how do we keep the robot still safety?
Okay, great question. Maybe it come from you, right? If anyone hack into your dog.
No, we get that question too. So it's a great question. So we're right now, a lot of the robots from our perspective, we actually do internal networks. So it's connected to, like I said, we have a central network that is used. Even from the cloud compute, we train the model first and then deploy them onto the edge side. So to being hacked, we also have deleted system with our dogs. So if there's any kind of hacking that goes into the program, we will shut down the robot directly, so it won't be able to move. So we wipe out the whole thing, even the brains. So yeah, we thought about that as well. It's a good question. Thank you.
Okay.
It's a great question, by the way. I mean, look, the one thing I've learned is I only know what I know today. So when it comes to security, so we all recognize that it's a moving target every single day. So, I mean, I can be very simplistic and say, don't connect it to anything. Well, if it doesn't connect to anything, it doesn't do any good. So I think we're always, as an industry, looking at that. Intrinsically, when I look at silicon, and this is something I've been working on internally, is, and I don't know, I'm going to go back to something that you mentioned as well, which is, how do I decide when something is unsafe? So it's more about, how do I decide when it's not secure? So what am I going to do? So what are the rules that you can put in place? What demands a shutdown? So, and I think from a silicon vendor, and I think it starts at the silicon layer in terms of what we need to do. Because intrinsically, I can't control what a hacker can do. There are such smart people on this planet that I don't even know what they're going to be capable of in a few years. But what I can do is, can I program something into a robot that says when it's asked to do something that doesn't make sense, it absolutely shuts down. You can't override that rule because it's not hackable. It's actually in machine code that sits at a security chip inside. So I believe there's ways you can approach it. I believe certainly on the software, when you expose anything, it's a moving target. And we will continue to develop technology to make things more secure. Data in motion, data in rest, control, all of these things we work on as an industry at infinitum. But ultimately, I believe where we're going in the future is we have to start intrinsically looking at what happens when it is broken into. That is the question we should be asking, because we have to accept it's going to be hacked.
Okay. Yes, exactly. So I think we are about time, and I will thank all these great panelists and speakers. And I don't think we have the answer yet today, right? So maybe next year we will still have this come back to have this great seminar and panel discussions. And I would like to thank all the audience who stay so late with us. And with that, give our panelists a round of applause. Okay.
Thank you.
So this concludes our session. Thank you.